lecture, basically. You've got sperm competition and you've got cryptic female choice. So, with that in mind, we'll start with sperm competition. And this was kind of recognized, like following a general pattern in behavioral ecology. It's usually the phenomena in males that get noticed and talked about first, whether or not they're actually more interesting. But Jeff Parker in 1970 alerted us to this possibility of sperm competition. And since then, it's been reported all over the animal kingdom, in birds, in mammals, in fish, in amphibians, and reptiles, and loads and loads and loads of invertebrates. It's particularly common in insects. And that is because multiple mating is very common in insects. But particularly, and we'll go through this in super detail if you take insect biology next semester, insects have something called a spermatheca, which is a sperm storage organ. The female has a sperm storage organ attached to her reproductive tract in which she can store sperm for from a few minutes all the way up to years and years and years. So a female ant, for example, a queen ant, mates once at the beginning of colony foundation and then stores the sperm for the next 20, 30, 40 years and can fertilize millions upon millions upon millions of eggs with that stored sperm. So the spermatheca allows insects to store sperm, and that results in a high degree of sperm competition. So Parker's, the main message coming out of this Parker, really important Parker paper, is that what really matters, it's going to really seriously matter to males how that spermatheca, sperm storage organ, works, and how sperm, or the dynamics of how sperm mix within a female's reproductive tract. So if you take as a kind of a null hypothesis, a kind of a baseline hypothesis, that there is perfect mixing of sperm within the female's tract. So you get, here are two males mating with a particular female, the red one and a blue one, and they both mate with her, and the sperm mix perfectly, which means that if she randomly chooses a sperm to fertilize her eggs, the first one coming out of this tract, this sperm storage organ to fertilize an egg coming down the oviduct, is going to have an even chance of fertilizing her eggs. And Parker summarized this as a value called the P2 value. The P2 value is the proportion of eggs that are going to be sired by the second male who mates with a female. And in this case, you can see if there's a fair raffle, if there's perfect mixing of sperm within the female's tract, the P2 value is going to be 0.5 because of the second male to mate has an even chance of siring the offspring. But Parker realized it doesn't have to work like that, because it's unlikely, depending on physiology and ecology and dynamics, it's unlikely that you're going to get perfect mixing of sperm. So you could, for example, have a low P2 value if what happens is the first male sperm fills up the reproductive tract or fills up the spermatheca, and the second male sperm is not, and any subsequent male sperm is not allowed in. It is kind of either the female closes it after the first mating, or there's no particular mixing going on, and the first male's ejaculate just gets excluded from the reproductive tract. In that case, your P2 value is going to be low. Like the first male to mate is going to get everything. But there are several other circumstances where you might get a high P2 value. For example, if sperm kind of stratify within the spermatheca, within the reproductive tract, so that the first male to mate sperm goes to the back, and the next male to mate kind of sits on top of it, so you get like a last in, first out situation. In that case, you'll get a high P2 value. The second male to mate will have an advantage. And also, if the first male's sperm goes in and the second male sperm kind of displaces it in a kind of a jet wash scenario, we'll meet something that does that later in the lecture. And what Parker realized is that this kind of seemingly arcane and ridiculous dynamics of how, literally, physically, how sperm behave inside the female's tract is going to have a huge knock-on effect for whether it's better to be the first male or the second male to be mating with a female. And typically, like the typical scenario is that the second male to mate often tends to have a high proportion of the offspring, to sire quite a lot of the offspring. And so that has selected for a bunch of behaviours in males to ensure that they are the last male to mate. You want to be the last male to mate with a female if your P2 value is high.